Okay, we are solving some numerical problem of chapter pressure, and very simple type of numerical problem which comes in examination. And what I want to say first, in this chapter there are basically three types of numerical problems which comes in examination. One is related to P equal to F by A. Two of them is given and third can be calculated. And second, Pascal's law, numerical problem related to Pascal's law. We are continuing the same. This one done in previous class. We are continuing the same Pascal's law how we use in numerical problem. And third one, the upthrust, the numerical problem related to upthrust. Let's start. One of the numerical problem is selected here. Look at this. The cross-section area of piston A and B is 20 cm square and 0.4 meter square respectively. Look at this is hydraulic pressure and there are two pistons A and B, and cross-section area of piston A and B is given here. Piston A 20 cm square and piston B 0.4 meter square. Look at this. This is different. This centimeter square, this meter square. How much load placed on piston B can be lifted if 240 Newton force is applied on A? This is the question. We have to find out the value of load. This is very simple numerical. The key fact, now I'm going to write this in, I'm going to write the information given in the numerical problem. Area of the piston A. Area of the piston A, which can be written as, let's say, A1. This A1 is equal to how much? 20 centimeters square. And area of the piston B, if we write A1 for A, then we can write A2 for B. A2 is equal to how much? It is 0.4 meters square. One is in centimeter square, another is in meter square. That's why meter square should be changed to centimeter square. And this change is the key factor of this numerical problem. Otherwise, this numerical problem is very, very easy. Look at this. Meter square can be easily converted into centimeter square by multiplying it with 100 twice. We multiply with 100 once to convert one of the meter into centimeter, and again we multiply with 100 to convert another meter into centimeter. That's why finally it becomes what? Centimeter square. Now if we multiply all this, then this is 4 having 30 centimeters square. Now force on piston A. Force on piston A can be written as F1 is equal to how much it is given here? 240 Newton. 240 Newton. And force on piston B, that can be represented by F2. This is question mark. Now the formula is very easy. It is written over there also. We have F1 by A1 is equal to F2 by A2. How this formula came? All of we know that it uses Pascal's law, and according to Pascal's law, if pressure exerted at any point in a confined liquid transmit equally in all the directions, look at this, the pressure on piston A transmit to pressure on piston B. That's why pressure on piston A F1 by A1 is equal to pressure on piston B F2 by A2. We are using Pascal's law. Okay. Value of F1 is given here. This is 240 Newton, 240 Newton, and A1 is given here. What is it? 20 centimeters square, 20 centimeters square. And F2 we are going to calculate F2, and A2 is given here. It is 4000 centimeters square. Now look at this, centimeter square cancel, 0 0 cancel. Now we can write like this. F2 is equal to 240 Newton into 400. This 400 goes to left hand side, let's say, and divided by 2. And if 2 2s are 4, this, and therefore what happens? F2 is equal to 24 2s are 48, having how many 0? 1 2 3. Now 48,000 Newton. Look at this, very simple. 240 Newton effort is now able to raise a load of 8,000 Newton. This is the magnification of force. This way we can solve the numerical problem related to Pascal's law and related to hydraulic press. Now I want to give another example of numerical problem which is related to Upthrust. Okay, look at this numerical problem. Study the given diagram and answer the following question is written, and diagram is given. Look at this, one of the body is shown to be weighing in air and the same is weighed in liquid, and displaced liquid is shown in another beaker which is weighed 8 Newton. This means weight of displaced liquid is given 8 Newton and weight of the body in liquid is given 15 Newton. These are the information. Now question is not completed. Look at this, number 1. What is the mass and weight of the body in air? This we are going to solve. How much upthrust is exerted on the body? This we are going to write something. This is not only numerical, some theoretical part is also connected. Number 3. In which principle the experiment is based on? We have to mention the principle, write down the principle, we have to state the principle. Now let's start. First we are writing given information, weight in water. We can say the liquid is water, that's why I am writing water, it's not given there. We can say water. How much is the weight of liquid in water? 15 Newton. And weight of the displaced water, or weight of displaced water means what? In this case, weight of displaced water is upthrust. According to Archimedes principle, upthrust is equal to weight of displaced liquid. That's why here weight of displaced water is upthrust, and this upthrust is given 8 Newton according to numerical problem. And weight in air, weight of the body in air, what it is? This is question mark. Now we are going to solve this. We have upthrust is equal to weight of the body in air minus weight of the body in liquid. This liquid is water. That's why we can write weight of the body in air is not given. Upthrust we have. That's why we are writing 8 Newton is equal to weight of the body in air, we have to calculate, minus weight of the body in water, 15 Newton. This is a very simple numerical problem, comes in examination. Weight in air is equal to 8 Newton, when this minus 15 Newton goes left hand side, plus 15 Newton, and therefore weight of the body in air, this is equal to 23 Newton. One of the part is answered, weight of the body in air, but mass is also asked. But mass can be calculated differently. We can write again, we know that weight of the body is equal to m into g. Weight is equal to mass into acceleration due to gravity, and we are going to calculate mass. Weight we know 23 Newton, and mass we are going to calculate, and value of g, average value of g can be taken as 9.8 meter per second square. It was taught in first chapter. Okay, I am continuing. Now mass, or m is equal to, when this goes to left hand side, 23 Newton divided by 9.8 meter per second square. This requires calculator. 23 divided by 9.8, this is equal to 2.346938. That's why after this we can write m is equal to 2.3469, that's why 35. Now unit of mass is kilogram. Kg. This way we can get answer of this question. Mass and this weight both are answered. Now let's go to second one. How much upthrust is exerted on the body? How much is the upthrust acting on the body? And you have to write this way. According to Archimedes principle, upthrust is equal to weight of displaced liquid. Therefore upthrust acting on the body is 8 Newton. This is, I am saying verbally, you can write answer easily. Number 3, in which principle the experiment is based on? This experiment is based on Archimedes principle. If you have to state Archimedes principle, you can say that when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid. This way we can solve the numerical problem and answer the question also.